Now let's look at one example in which we convert a rectangular equation to the polar equation. Let's look at the problem 88. So page 639, problem 88, we have the y equal to -6. And we know this is the equation, and the graph is a line, right? So it's a horizontal line. And we know y is equal to r times sine theta. So we just replace this y by the r times sine theta. Then we get r times sine theta equal to -6. And then we divide both sides by sine theta. Then we have equation. Okay, we have the polar equation for this graph. So that is a -6 over the sine theta. So definitely, in this case, for this line, the polar equation is much more complicated than the rectangular equation, right? But for the line going through the pole, the polar equation is extremely simple. Let's move to the next page. And let's first look at the polar equation, theta equal to 45 degrees. And you can see in this equation, we don't have r, right? It's independent of r. So to plot this graph, we may choose some points from this graph. Say we may let r equal to 0, then theta still equal to 45 degrees. And we may let r equal to 2, then we still have the 45 degrees, right? And then -3, 45 degrees. So now you can plot all these points, 45 degrees, like this. And then 0, 45 degrees here, right? 2 and 45 degrees here. And then -3 and 45 degrees here. So actually, this is just a line, right? Just the line with this inclination angle equal to 45 degrees. So it's quite simple for the line going through the pole in the polar coordinate system. So anyway, theta equal to constant just stand for a line going through the pole. Now, another extreme case is the r equal to constant. How about the r equal to 2? So we know, actually in this case, the graph of this polar equation is just a circle with the pole as the center and the 2 as the radius. So you can draw a circle like this. And then this is equal to 2. So any points on this circle with r equal to 2, right? And the angle can be anything. So r equal to constant, this is just a circle with the center at the pole and this constant and the radius equal to this constant. Then done.